Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video is one of a series designed as a study aid for prospective teachers preparing for the math portion of the General Knowledge Test, a part of the Florida Teachers Certification Examinations. The math portion of the General Knowledge Test is divided into 4 categories of understanding that the state of Florida considers important for all professional educators to master before issuing a professional educator certificate. These 4 categories are number sense concepts and operations, geometry and measurement, algebraic thinking and the coordinate plane, and probability, statistics, and data interpretation. Each of these subjects will be covered in separate videos. This video covers probability, statistics, and data interpretation and is divided into 7 skills. Analyze data presented in various forms to solve problems. Analyze and evaluate how the presentation of data can lead to different or inappropriate interpretations in the context of a real-world situation. Calculate range, mean, median, and mode of data sets. Interpret the meaning of measures of central tendency and dispersion in the context of a real-world situation. Analyze and evaluate how the selection of statistics can lead to different or inappropriate interpretations in the context of a real-world situation. Solve and interpret real-world problems involving probability using counting, tables, and tree diagrams. Infer and analyze conclusions from sample surveys, experiments, and observational studies. In this video, we will solve sample problems related to these skills that will be similar to those you encounter in the math section of the General Knowledge Test. Please note that the General Knowledge Test is a multiple choice test, but for the sake of instruction, I have omitted incorrect distractors in favor of solving each problem directly. Additionally, a basic 4-function calculator is provided for use during this test. For demonstration purposes, I will calculate all arithmetic steps without such an aid. The time for the test is limited. Therefore, it is recommended that you use the calculator where appropriate. Cassandra must average at least 70 on 3 math tests to get a passing grade. Her scores on the first 2 tests were 64 and 80. What is the minimum score she must get on the 3rd test in order to pass? A passing grade would be achieved by a grade of 70 on all 3 tests. This would give her a total of 210 out of 300 possible points on these tests. Cassandra has a 64 and 80 for a total of 144 points on 2 tests. Therefore, Cassandra needs 210 minus 144, or a score of 66 to earn a passing grade. Ms. Jameson compared the math test scores of her students from her morning and afternoon classes. This is called a stem and leaf chart. The stem is in the center and represents the tens digit, and the leaf represents the ones digit for the data collected. For example, the morning class had test scores of 75, 77, another 77, then 80, 82, and so on. Whereas the afternoon class had scores of 67, 70, 72, another 72, 76, and so on. This method is often used as a way of organizing data for easier observation and condensed space. Which of the following statements is true? The range of the morning test scores is greater than the range of the afternoon test scores. The range of a set of data is the difference between the highest and lowest data point. The range of the morning test scores goes from a high score of 99 to a low score of 75, a range of 24. The afternoon scores range from a high score of 96 to a low score of 67, a range of 29. So the afternoon class has a higher range, making this statement false. The mid-range of the afternoon test scores is greater than the mid-range of the morning test scores. The mid-range of a set of data is calculated by adding the lowest and highest data points and dividing by 2. For the morning class, this gives us 99 plus 75, which is equal to 174. 174 divided by 2 is 87. For the afternoon class, 96 plus 67 is 163. Then we take 163 and divide by 2 to get 81.5. This means the morning class has the higher mid-range, making this statement false. The median and mean of the morning scores is greater than the median and mean of the afternoon scores. The median is the middle data point in a data group that is arranged from lowest value to highest. If there is not one true middle, then the average of the two middle scores is taken. I've arranged the data on a vertical chart in order to better see this concept. Since there are 20 entries, the median will be between the 10th and 11th values. In the morning classes, these are 86 and 87, so the median of the morning class is 86.5. In the afternoon class, the 10th and 11th values are both 83, so the median of the afternoon class is 83. To arrive at the mean, we add up all the data values and divide by the number of data points. In the morning class, the sum of all the entries is 1,751. 1,751 divided by 20 is 87.55. In the afternoon class, the sum of the entries is 1,640. We then calculate 1,640 divided by 20. This is made easier by dropping the zeros at the end of both numbers. 164 divided by 2 is 82. The mean for the morning class is 87.55, for the afternoon class 82. Both values for the median and mean are larger for the morning class, making this statement true. The mode of the morning test scores is less than the mode of the afternoon test scores. The mode is the data point that appears most often in a set. In the morning class, the data point 86 appears 3 times, making it the mode. In the evening class, the data point 83 appears 3 times, making it the mode. This means the morning class has the highest mode value, making this statement false. A girl has 4 red, 5 green, and 2 yellow balls. She chooses 2 balls randomly without replacement. What is the probability that the first one is red and the second one is green? When making the first selection, there are 11 total balls and 4 of them are red. Therefore, the probability of selecting the red ball is 4 out of 11. When making the second selection, since the first red ball was not replaced, there are now 10 balls, 5 of which are green. Therefore, the probability of selecting the second ball green is 5 out of 10, which can be simplified to 1/2. Because we are looking for the probability of both events happening, we multiply both probabilities. 4 over 11 times 1/2 equals 4 over 22, which can be simplified to 2 out of 11. A local restaurant is offering a lunch special, which includes a main course, vegetable, beverage, and dessert for $8.50. Guests may choose from ham, chicken, fish, or beef for the main course. They may choose potatoes, peas, green beans, broccoli, or carrots for their vegetable. Coffee, tea, milk, or soda are the beverage choices. Cake, pie, or ice cream are the dessert choices. If a guest selects one item from each of the 4 categories, in how many ways can a meal be ordered? Since each selection is independent of the others, calculating the number of different combinations is simply a matter of multiplying the number of choices for each course. 4 main courses times 5 vegetables times 4 beverages times 3 desserts equals 240 different dinner combinations. A high school has received $6,000 in donations and grants to build a new computer lab. The following graph shows how the school plans to spend the money. How much of the money in the budget will not be spent on either computers or software? If you look at the percentages for budget items, you see that 43% will be spent for computers and 18% for software. Add these together to get 61%. Subtract that number from 100% to get 39% of the budget is for the other items. $6,000 times 0.39 is $2,340 on items other than computers and software. Use the graph below to determine which of the following statements is true. The Honda Civic can travel the most miles per gallon. Looking at the graph, the Honda Civic gets 36 miles per gallon, while the other two get less, so this statement is true. The Toyota Camry can travel the fewest miles per gallon. The Toyota gets 31 miles per gallon, which is less than the other two, so this statement is also true. The Honda Civic's mileage is approximately 2 times that of the Toyota Camry. From the graph, the Honda Civic gets 36 miles per gallon, yet the Toyota Camry gets 31 miles per gallon. This is not twice. The scale of the chart gives an incorrect impression in comparison, so this statement is false. The Chevrolet Aveo gets approximately 3 more miles to the gallon than the Toyota Camry. The Aveo gets 34 miles per gallon, and the Camry 31, which is 3 more, so this statement is true. The distribution of heights of adult men in the United States is shown in the graph. Out of 2,000 randomly selected men, how many would you expect to be over 6 feet tall? This graph represents the standard distribution of data where 5 foot 9 inches is the mean. In all standard distributions, 68% of the data falls within the first standard deviation of the mean, in this case between 5 foot 7 and 6 feet. Also, 95% falls within 2 standard deviations of the mean, in this case between 5 foot 6 inches and 6 foot 2 inches. Finally, 99.7% falls within 3 standard deviations of the mean, in this case between 5 foot 3 inches and 6 foot 3 inches. To find the percentage of adult men over 6 feet, we first observe that half are over 5 feet 9 inches. Then we need to remove that portion of the first standard deviation. Half of 68% is 34%. 50% minus 34% is 16%. This represents the percentage of men that can be expected to be over 6 feet tall in any population with a standard distribution of heights. 2,000 men in the sample times 0.16 is 320 men over 6 feet tall in this sample. If you have further questions on this video or wish to attend an in-person FTCE workshop, please contact the Academic Support Coordinator at either St. Augustine, Palatka, or Orange Park campuses. Thank you, and good luck in your teaching career.